All right, for the Chapter 3 test review, the first three questions we have to use the picture off to the right, and the first question says to identify a pair of parallel planes. So each side of that figure is a plane, and we need to figure out which sides are parallel. So looking at it, the edges, the rectangle shapes, are all touching, so those are definitely not parallel. The triangle that's in the front also has that same triangle in the back that we really can't see. So those two would be parallel. If we were to extend those triangles and make them bigger, they are never going to touch. So a pair of parallel planes in this figure would be triangles ABC and triangle DEF. And then we need a pair of parallel segments. Well, remember those little arrows indicate parallel lines. So we can say segment AB and segment DE. And then a pair of skew segments. And skew segments are not coplanar and are not parallel. So if we picked, let's say, segment DF, it's on the front triangle, I could say that would be a skew segment with maybe segment BC. Definitely not parallel and definitely not on the same side. All right, so for number 4 and 5, we need to find each angle measure. And looking at this picture here, we have alternate interior angles because they are on the inside of the parallel lines. And we know that alternate interior angles are equivalent. So we can say 17x plus 8 is equal to 13x plus 24. So the first thing I'm going to do is move the 13x so that we have the x's on the same side. Then I'm going to move that 8. 24 minus 8 would be 16. And then I'm going to divide by 4. So x is 4, but we have to find the angle measure. So I'm going to plug that back into one of the other equations. So it doesn't matter which one. So I'm going to do 17 times 4 plus 8. 17 times 4 would be 40 and 28. That would be 68. And add 8 to that would be 76 degrees. So the angle measures here are 76. For here, these two angles are alternate exterior. So they're on opposite sides of the transversal and they're both on the outside. So those angles, alternate exterior, are also equal. So we're going to do 33x plus 35 is equal to 26x plus 49. So I'm going to move the 26x first since it's the smallest. And that would leave us with 7x plus 35 equals 49. And I'm going to minus the 35. That would leave us with 14. And then I'm going to divide by 7. 14 divided by 7 is 2. So x is 2. We need to figure out what one of these angle measures are. So I'm going to plug it into the top one. Doesn't matter which one you plug it into, you're going to get the same answer. So 33 times 2 would be 66 plus 35 would be 101 degrees. Those angle measures are 101. Now, using the given information and theorems and postulates you have learned to show that F is parallel to G, and I didn't label those. The measure of angle 1 is 26x plus 38, and the measure of angle 5 is 17x plus 56, and we know x is 3. So here is 1, and here is 5. So those are corresponding angles. They're in the same spot, but on a different group. So we need to know that. We also need to plug 3 into each one of these. So we are going to have 26 times 3 plus 38. And we're also going to have 17 times 3 plus 56. So 26 times 3 is 78. And then we need to add 38 to that. We get 116. Over here, we need to do 17 times 3, which is 51, and we need to add 56 to that. So now that I did this and I didn't get the same answer, I'm realizing that I typed in the wrong number here. So I have already changed this on your review that you are going to do. So this should be a 23 here. So 23 times 3 is 69, and then we have to add 38 to that, which gives us the 107. Okay, so we have just shown that they are equal to each other, and those are corresponding angles. So to prove that F is parallel to G, we can say that's because of the converse of corresponding angles. Because remember, if we prove that the angles are the same, then we can prove that the lines are parallel. So that's our answer there. Okay, number 7, we have to use the slope formula to find the slope of each line. And the slope formula is y2 minus y1 over x2 minus x1. So y out of the second is 4 minus y out of the first is 5. And x out of the second is 4 minus x out of the first is 2. So 4 minus 5 is negative 1. And then this becomes plus, so 4 plus 2 is 6. So the slope of that is negative 1/6. Over here, when you have a graph, we can use the slope formula, find two ordered pairs, and plug that all in. Or we can do it a little bit quicker, and we can do rise over run. So I'm going to pick 2 points. Doesn't matter which 2 points I pick. I'm going to go from here up and over. I went up 2 and I went over 1 to the left. So rise 2, went up, so it's positive. Then I went left 1, so that's going to be a negative 1. And that simplifies down to negative 2. So the slope of that line is negative 2. All right, number 9 says write the equation through negative 3, negative 4 with the slope of 2/3 in point slope form. So remember, we have to do y minus our y, which was negative 4, equals our slope times x minus our x value, which is negative 3. So now I need to go in and clean that up a little bit. Minus a negative is going to be a plus in both situations. And then we have our point slope form. In our last question, we have to determine if these are parallel, intersecting, or coinciding lines. So we have to solve them both for y before we can do that. So I'm going to add 3x to both sides. And then I have to divide everything by 2. So I'm going to have 5 over 2 plus 3 over 2x. And then we have to do the same thing here. Minus 6x. And I'm going to divide by negative 4. 8 divided by negative 4 is negative 2, and negative 6 divided by negative 4 is going to be a positive, and 6 over 4 would reduce to 3 over 2x. And now we need to compare these two lines. So the only thing that I see that they have in common is the same slope. So if they have the same slope and different y-intercepts, that tells us they are parallel lines. They don't cross.